Okay, let's give you guys some more practice. So here, find the derivative of y equals blah blah blah, or another way of putting it, find dy by dx, given that y is this here. Okay, so press pause and have a go. Okay, start out by sketching this. Start out by roughly sketching this graph. So your graph will look something like this, and you when x is small, it wants to do this straight line here. So intercept of 3, gradient of -2. So intercept of 3. So we're going to guess somewhere here, and then when it's big, it will want to do. When x is big, it wants to do this. So it's a negative quadratic. So we're gonna guess it to be something like this. So now join the three together. So it will look something like this. Okay, roughly like this. So now yeah, set up 2 points. It could be anywhere. We're going to choose this point and this point. Well, in fact, you can set up any point, A and B here, A and B. It could be any point. It doesn't always have to be in the positive realm. So now well, set up 2 points and then say to yourself, the gradient that exists between A and B is so the gradient that exists between A and B is given by, well, don't forget this here we're going to say is x. This is x plus h. Okay, hang on. So the gradient that exists between A and B is given by f of x plus h. Take away f of x, and then divided by h. So remember, h is from here to here. Okay, and then once so the gradient that exists between A and B is given by this. But then you want to get B to move closer and closer towards A. You want to decrease h until it gets to until it tends to 0. So the gradient that exists between A and B is given by this. But the true gradient, which is dy by dx, is given by you taking the limit as h tends to 0 of this thing here. Okay, so the true gradient is given by this here over h. Okay, so once you're at this stage here, remember it's you putting x plus h into your original function, if you like, here into here, and then x plus h into here. Okay, that will give you this thing here. So this bit here is really, it's in a way like f of x plus h here, and then this bit here is your normal f of x here. It's your normal well, it's this f of x is like this bit here. Okay, so hang on. So this whole thing here becomes this. Okay, so hang on. So now let me just clear this up. Okay, so we are currently here. Now it's just a matter of using algebra to tidy this whole thing up. So at the moment you've got this bubble here. Remember, you've got to do the power first, and then you take into powers are more important than negatives. So you would have to do this first. Okay, so well, square this, so it will then become this, and then this thing here, -2 times x, that will give you this, -2 times h, that will give you -2h, and the 3 is on its own. Okay, so the 3 is on its own, and then this bit here, you've got minus a minus here, so that becomes a positive x squared, and the minus times a minus, so this here becomes a positive, and a minus times a positive, it becomes a negative. Okay, and then hang on, and then what? And then yeah, so now tidy this up. So this here becomes this. This here becomes negative 2xh, and then this times this will become a negative. This stays the same, stays the same, well, they're all the same, so take the whole lot down here. Okay, so the next step is to note that this thing and this thing here, they will kill off each other. Okay, and what else would, oh yeah, you've got this thing here will kill off with this thing here, and then you've got a 3 that will kill off with this -3 here, so that leaves you with this, which is this here, this here, which is this, and the last bit here, take it down. Okay, so the next step is to notice that h is in common here, h is in common here, h is in common here. Factor out the h, and then these two will kill off each other. Okay, these two will kill off each other, leaving you with just this bit here. Now this is nice and simple now. So get h to head towards 0. You see, when h heads towards 0, you're going to minus something that's near to 0, which is pretty much, you can consider it as 0. So take the limit as h tends towards 0, that will leave you with this. So dy by dx is given by this. So you can think of this as the gradient graph, if you like, is given by this. So hang on. So originally our graph would look like this. Now the gradient graph, which is our dy by dx, you've got to think of this graph as a gradient of the red graph here. So it's a gradient. So if you want to know, so if you look at this point here, you know the gradient here is 0, because right here is, well, the gradient here is 0. But suppose you don't know where this bit is. You can just look at your dy by dx and ask yourself, when would it, so looking at the gradient, if I just look at the gradient, when will the gradient be 0? Well, the gradient is 0 where along here. The gradient is 0 right here. The gradient will be 0 at this point here. So that there is 1. So my point is that so if you don't know where this point is, when given a graph like this, and you want to know where the highest point is, you can just find dy by dx of this whole thing here, and then looking at the dy by dx and ask yourself, when is dy by dx 0? Well, looking at this here, dy by dx is 0 when x is -1. So you know that looking at this here, the highest point will be at negative when x is -1. Well, anyway, looking at this here, this is your normal graph here, but this is your gradient graph of the red line. Okay,